Hey everyone, welcome back to Mr. Psycho. Here on this channel, we like to go beyond the surface and explore the strange and unexplained, those mind-bending theories that just don't fit neatly into the boxes of everyday science. Today's topic? It's not your everyday physics lesson. No, today we're diving into one of the most mysterious and controversial interpretations of quantum mechanics, the de Broglie-Bohm theory, also known as the pilot wave theory. Now, imagine for a moment that everything you thought you knew about reality was wrong. Imagine that there's another layer, a hidden order in the universe that goes far beyond what we can see or measure. What if the particles that make up everything we see, from stars to sand grains, from our own bodies to the farthest galaxies, aren't just randomly bouncing around but are following a predetermined path? And what if each particle, no matter how tiny, had a kind of secret guide that told it exactly where to go, like an invisible hand steering it along an invisible track? For most people, quantum mechanics is already weird enough. It's a science where particles can be in two places at once, where measurement changes reality, and where everything seems to be governed by randomness and probability. It's as if the universe is playing dice, rolling randomly to decide where a particle might appear next. That's what mainstream quantum mechanics, especially the Copenhagen Interpretation, tells us. This interpretation, which many physicists hold, says that particles don't have fixed positions or paths. They're just probability clouds, a blur of possibilities until someone comes along to measure them. But that's not the only way to see things. In the 1920s, when the mysteries of the quantum world were still being explored, a young French physicist named Louis de Broglie dared to ask, what if particles do have specific paths, but we just can't see them? De Broglie was one of the first to propose that particles like electrons could act not only as particles, but also as waves, a groundbreaking idea that helped launch the field of quantum mechanics. But he went a step further. De Broglie suggested that these particles weren't moving aimlessly. Instead, they were being guided by a hidden wave, a pilot wave, that directed their paths. For years, de Broglie's ideas sat on the sidelines. The physics community embraced the randomness and uncertainty of the Copenhagen Interpretation and largely left de Broglie's ideas behind. But then, in the 1950s, an American physicist named David Bohm picked up where de Broglie left off. Bohm was intrigued by the idea of hidden variables, unseen factors that might determine the precise movements of particles. He revived and expanded de Broglie's theory, proposing that every particle is part of a larger interconnected web, with each movement guided by a pilot wave that knows the state of every other particle in the system. Think about that for a second. Imagine a vast network of waves stretching across the universe, all intricately connected. This web of pilot waves would mean that every particle's motion is influenced by every other particle, no matter how far away. It's like particles are actors on a stage, each following a hidden script, each step carefully coordinated with every other actor in the universe. But the question remains, why haven't we heard of this theory before? Why don't we all learn about de Broglie-Bohm theory in school? The answer is as strange as the theory itself. You see, de Broglie-Bohm theory isn't just about science, it's about philosophy, about how we choose to interpret the world. Most physicists were drawn to the simplicity of the Copenhagen Interpretation, with its probabilities and uncertainties, which seemed to fit the randomness they saw in experiments. They weren't ready for a theory that suggested there might be something hidden, something beyond the reach of our measurements. Yet, the de Broglie-Bohm theory has a unique appeal. It tells us that the universe isn't random, that there's a deeper order at play. According to this view, particles have definite paths, and if we could only see the pilot wave that guides them, we'd be able to predict their movements with perfect accuracy. This goes against the grain of the Copenhagen Interpretation, where uncertainty and probability rule, but it offers something the Copenhagen Interpretation doesn't: a sense of certainty, a sense of determinism. Imagine what it would mean if this theory were true. It would suggest that every action, every movement in the universe is already laid out, governed by a network of hidden forces that we're only beginning to understand. It would mean that nothing is truly random, that everything is connected, from the tiniest particle to the largest galaxy. So, today, we're going to peel back the layers and see what the Broglie-Bohm Theory is really about. We're going to look at the hidden variables, the pilot wave, and why physicists like Bohm believed that randomness was only an illusion. We'll talk about how this theory could reshape our understanding of the universe and why, despite its elegance, it's still on the fringe of mainstream science. So grab a seat, get comfortable, and let's take a journey into one of the strangest, most mind-bending ideas ever conceived. This is a story about hidden order, about secret paths, and about the mystery at the heart of reality itself. You're going to see the world in a whole new way by the end of this video, so let's dive in. Thanks for sticking around to the end of this deep dive into the Broglie-Bohm Theory. If you're as intrigued by the mysteries of the universe as I am, don't forget to like, subscribe and hit that bell icon. Let me know in the comments what other mind-bending theories you'd like me to cover next. Until next time, stay curious, stay questioning, and as always, stay a little bit psycho.